Hello everyone, welcome to the summer CS5593 data mining project called Mushroom Classification. So we are Team 7 and in the next few minutes we'll be walking through the following topics. The introduction, related work, methodology, data collection, data pre-processing, classification models, performance evaluation, graphical user interface, results and conclusion. Coming to the introduction, mushroom is an important fungus which is a good source of vitamins and proteins. So based on the features of mushroom, they can be classified as edible mushroom or poisonous mushroom. Talking about the ancient importance of mushroom, mushrooms are known as food for the god. Mushrooms are also called as saprophytes as it is a type of fungi, means it doesn't contain chlorophyll. Also, it is estimated that there are 1.5 million species of mushrooms, and in which only 6,900 have been identified. So, based on all of those, we have classified them namely as poisonous or edible. And also, only 2,000 species have been identified as edible, and the remaining are poisonous. So, we need to find out which is edible and which is poisonous. Mushrooms are extremely beneficial to the human health. So they also have medicinal properties that can be used to treat diseases such as cancer. However, we mainly recognize the mushrooms which is poisonous and edible. It is not simple to grow mushrooms. You need to know all the environmental characteristics to grow a mushroom. Also, each mushroom has distinct characteristics known as features that assist them in determining because of its toxicity. The mushroom gathering process is the mushroom hunting, so it is also called as mushrooming. Eating poisonous mushroom may cause allergic reactions in some people. So, coming to data mining. Data mining is the process of extracting valid, previously unknown, and actionable information from large sets of data. So this information can be used in decision making or and also classification. So classification is a supervised learning as it will map into predefined groups that are determined prior examining the data. So this classification mainly involves two steps, that is the testing of the data and training of the data. So in our project, we are mainly using the following techniques, the following techniques for classification. So they are the k nearest neighbors, logistic regression, decision trees, and artificial neural networks. So coming to the evaluation matrices. So evaluation matrices are used to measure the quality of the statistical or machine learning model. So in our project, we have used the accuracy, F1 score, precision, and recall. So it mainly helps to choose the best model among the variety of the models that are present. So coming to the related work, after referring to the various research works on mushroom classification, it is found that Chumong presented the outcomes of classifying mushrooms based on their physical traits. So the research technique includes data collection and data cleaning, use of various data mining algorithm for classification, output verification and result interpretation. So with his work for performance evaluation, it is found that KNN outperformed others with 100% accuracy amongst the different algorithms. So the next one is the DVSIC have applied the KNN and decision trees for processing the historical data from e-learning platform to predict the success of education that the company wants to set up for his employees. So with the test accuracies of 72.17% and 76% when compared to the decision trees which is 67.47% and 72.27% respectively. So coming to the third one, Shobana has employed the data mining techniques to classify the cancer drug that can select only few potents of drugs that can be tested in the clinical phase. As the data for this experiment consists of 43 features, a feature selection technique called as select from model is employed to identify the 30 relevant features after replacing the null values in the data. ANN outperformed the remaining techniques with an accuracy of 84.5% on the test data when relevant to 30 features that are used for classification. Methodology. The implementation of this project is mainly divided into five phases: data collection, data pre-processing, classification model, performance evaluation, and user interface. Coming to the first phase, it is data collection. So the data set is obtained from the Kaggle website, and the data is subdivided into 8124 rows and 23 attributes.
So when it comes to data pre-processing, in the data that we collect from the real world, it is often possible to have data corruptions. These data corruptions sometimes significantly affect the data mining tasks. The data pre-processing helps us to handle the corrupted or unwanted data and allows the system to have a data set with more valuable information after the pre-processing stage. So we can define the data pre-processing as a data manipulation or transformation technique used to enhance the performance of machine learning algorithms and make the data mining tasks more useful and efficient. In this project, we have used three pre-processing tasks: handling missing values, label encoding, and data normalization. We have not used outlier detection in this project because all the features in this data are categorical data types and we don't have to perform outlier detection in categorical data types. So handling missing values is one of these techniques. So here, sometimes it's possible to have no data value stored in an observation, which are called missing values in the data. We need to handle the missing data because it can cause significant effect on the conclusions drawn with missing values in the data. There are two famous techniques to handle these missing values. One is to ignore the missing value by replacing it with zero. Second is to impute the missing value with descriptive statistics such as mean, median, or mode. When it comes to imputing by mean is to replace the missing value with the average value of all the data points. And imputing by median is to replace the missing value with the middle value of all the data points arranged in order. Imputing by mode is to replace the missing value with the most frequent value of all the data points. So in this project, since the data is categorical data type, we have used mode-based impute missing values technique. So another technique is label encoding. Here, before sending the data to the machine learning algorithms, we need to make sure to convert all the data types to the numerical data because machine learning algorithms can only work on numerical data types. Label encoding is a technique used to convert the categorical variable types to the numerical values. In this project, we have implemented the label encoding by getting the unique values of the data, sorting the unique values, assigning numerical label for each of the unique value, and then replacing the categorical value with the assigned numerical label. Coming to the next technique, which is normalization. Data normalization is a data pre-processing technique that is used to reduce the range of an attribute of the dataset to a smaller range. Since the frequency of larger values have an advantage over the smaller ones, normalization is done on the attributes so that they have same influence on the distance measured between instances. Many classifications like CNN and artificial neural networks benefit greatly from normalization. There are two types of normalization techniques, which are min-max normalization and Z normalization. Min-max normalization uses minimum and maximum values to normalize the data, whereas Z normalization uses mean and standard deviation to normalize the data. When it comes to min-max normalization, as mentioned, min-max normalization uses minimum and maximum values to normalize the data. This method performs a linear transformation on the original data and rescales the range of the data to 0 and 1. Here, this is the formula where we first subtract the minimum value from the original value and divide it with maximum minus minimum to get the new value. So now we are discussing about the classification models. When it comes to classification, it is the process of categorizing each item in a set of data into one of a predefined set of classes or groups. Classification is a data mining function that categorizes or class items into a collection. Classification's main goal is to accurately predict the target class for each case in the data. So in this project, we are using few of the algorithms which are k-nearest neighbors, decision trees, logistic regression, and artificial neural networks. So k-nearest neighbor is one of the classification algorithm we have implemented in our project. When it comes to k nearest neighbors, this is a simple, easy to implement, supervised machine learning algorithm that can be used to solve the classification problem. The algorithm predicts the label of data points by just looking at the majority in its closest neighbors. Uh, for a data record T to be classified, its k nearest neighbors are retrieved and this forms the neighborhood for T. Majority voting among the data records in the neighborhood is usually used to decide the classification for T. The choice of K is crucial in the success of this classification model. So there are many ways of choosing the K value, of which the simplest one is to run the algorithm many times with different K values and choose the one with the very best performance. Then we can break the algorithm into four steps. That is, we can break the k nearest algorithm into four steps. So in the first step, we load the training and testing data. When it comes to the second step, from each new unlabeled data, we calculate the Euclidean distance with all the training data points using the formula which is shown in the slide. And in the next step, we will choose the k value and find the k nearest neighbors. And then finally, we will try to assign the class containing the maximum number of nearest neighbors. So the KNN classification model has both its advantages and disadvantages. When it comes to advantage, the K nearest neighbors algorithm is very simple to implement and robust to noisy training data. And when it comes to the disadvantage, here we need to define which K value to use. And this model has high cost of computation compared to other algorithms. So the algorithm is slow for large datasets. And the other disadvantage may be this model also requires large memory, so its space complexity is high and inefficient.
So the next model is logistic regression. Logistic regression is a supervised learning algorithm that is used to predict a dependent categorical target variable. So in essence, if you have a large set of data that you wanted to categorize, logistic regression can be used. So it allows the algorithms used in machine learning applications to classify the incoming data based on historical data. So as an additional relevant data comes in, the algorithms get better at any predicting classifications within datasets. It is also used for the binary classification. So initially the logit function is calculated using the following formula and they are represented as B is the bias, W and X are the weight value corresponding to the kth attribute respectively. You can see the graphs of the linear regression and logistic regression in the slide. So the main difference between both of those is that logistic regression provides a constant output while the linear regression provides a continuous output. So the sigmoid function. So the sigmoid function is also called as logistic function. So it decides which value to pass as output and what not to pass. So the formula is mentioned in the slide. We also need to find the gradient descent. So the gradient descent is used to update the weights corresponding to each attribute as well as the bias. So it is an iterative optimization algorithm which finds the minimum of a differentiable function. So the cost function. It is to minimize the cost function, the gradient descent corresponding to each weight is calculated, where m is the number of examples in the training set, yi is the label of the given example, ai is the predictor label. So similarly, the change in the weights and bias are also calculated. So after that is done, the weights and bias are updated. So they are mainly represented as B is the bias and dB is the change in the bias.
Artificial neural networks. Artificial neural networks, also called ANN, are multi-layer nonlinear networks where the output of one layer will be passed as an input to the other layer. They have emerged as an important tool for the classification. ANNs are actually data-driven self-adaptive models. That means they can adjust themselves to the data without any explicit specification of the distribution of the underlying model. Secondly, they are universal function approximators. That means they can approximate any function with the arbitrary accuracy. Each ANN had typically three types of layers, namely the input layer, one or more hidden layers, they are also called the intermediate layers, and one output layer. The learning phase in ANN is actually consists of two phases. The first one is called the forward propagation, and the second one is called the back. The building blocks of ANN are actually called the nodes. Every node in one layer will be connected to every other node in the next layer. In the forward phase, the output of a node will be multiplied with the weights of its outgoing arcs. Each one of these multiplication results contributes to the input of the nodes in the next layer. To determine the output of a node, an activation function can be used, which will generate an output by taking into account of all the contributions from its input links. The learning process in ANN is actually an iterative operation. That means in the forward phase, the input patterns will be fed into the input layer of the system. Then each hidden layer does the computation and forwards the activation values to the next layer in the chain of the network, and eventually the result reaches the output. If we consider node 1 in the hidden layer number 1, and if we observe if we observe its output, it will be passed to every node in the next layer, that is in the hidden layer number 2. Typically, if O be the output of a node, then O is calculated using an activation function. Typically in our case, it is the sigmoid function. In the next phase, that is in the backward propagation, the network will learn from the mistakes it made during the forward phase. The output layer computes the errors based on the observed output and the actual output. These errors will then be backpropagated by using the backpropagation formula, and from this, these errors will be propagated from the output layer till the first hidden layer. The main advantage of ANNs is its parallel processing capability. ANNs have the numerical strength that they can perform more than one task at the same time. Secondly, corruption of one or more cells in the ANNs doesn't prevent them from generating the output. This feature makes them actually a fault tolerant. The main disadvantage of ANN is its unexplained behavior. Since they are black box systems, it will be hard to tackle in case of errors. Also, they are hardware dependent. That means if we have less GPUs in our system, then the training phase in ANN will take a long time to complete.
Now we are going to discuss about the decision tree classification model. Decision tree is built using the recursive partition of the instance space, and it can be easily interpreted to non-experts. The tree is divided using the values and the attributes, and the building blocks of the decision tree are called nodes. There are three different types of nodes in the decision tree, which are root node, internal nodes, and the leaf nodes. When it comes to a root node, it has no incoming edges, but only have the outgoing edges. And the nodes that has only one incoming edge and have two or more outgoing edges are called internal nodes or test nodes. Then all the other nodes that have an incoming edge and no outgoing edges are called leaf nodes. So they are also called as terminal nodes and decision nodes. In a decision trees, each internal node splits an instance space into two or more subspaces. This instance space splitting is done using values in an attribute. Each leaf node contains the value of a class label, whereas the instances of the data set are classified by diving down from the root of the tree to the leaves by following the outcomes of the test. Each node is usually labeled with the attribute it tests, and each branch is labeled with its corresponding values. Also, the decision tree employs a greedy strategy that it makes the best local optimal choice at each stage, which overall leads to the best solution. Hunt's algorithm is a simple approach to build the decision trees. So it employs a recursive way to build the trees by dividing and training the data set into purer subsets. The Hunt's algorithm works as follows. So when it comes to first step, if all the records of the node belongs to the same class, then T is a leaf node labeled. And then if the records at the node belong to one or more subclasses an attribute test condition will be selected to partition the records into the smaller subset. A child node is created for each outcome of the test condition, and the records are distributed to the children based on their outcomes. So this algorithm is then applied to all the child nodes until leaf nodes are obtained. Then to determine the best split, we can use three methods in this process, which are entropy, Gini index, and classification error. When it comes to entropy, entropy is the measure of the randomness or uncertainty of the system. It is defined in the formula as shown. Here, we first calculate the probability of a class label at a node, then multiply with its log and sum up all the nodes. Sum up all the nodes. And then when coming to Gini index, it measures the probability of the incorrectly classified variables. The Gini index varies between 0 and 1. 0 indicates that only one class exists, and 1 indicates that the elements are randomly distributed, and 0.5 indicates that the elements are distributed equally. And when it comes to classification error, it occurs when an incorrectly defined class labels. So all the entropy, Gini index, and classification error have been represented with the mentioned formulas in the slide, whereas the P of IT denotes the number of records belong to class I at node T, and C be the number of classes at the node T. And also, when it comes to the gain, it is obtained using the formula presented as there, where I of parent is the impurity measure of a given node, N is the total number of records at the parent node, and K is the number of attribute values. Then the determination of goodness of a test split is done by comparing the degree of impurity of the parent node, that is, before splitting, with the degree of impurity of the child nodes after splitting. The larger the difference, the better the test condition.
Performance evaluation. It plays a vital role in determining the efficiency of an algorithm. So these matrices help us to choose the best model among the different models that we have implemented in this project. So some of them are accuracy, precision, recall, and F1 score. So each of these evaluation matrices uses the confusion matrix. So the representation of the confusion matrix is shown there. So each row represents the actual class and each column represents the predicted class. So coming to the definitions of each of them, we have accuracy. It is mainly defined as the ratio of the correctly predicted labels and the total number of predictions. Precision. It is the ratio of true positives and the number of instances the model has predicted for the positive class. And the next one is recall. So it is a ratio of true positives to the number of positives in the ground truth. F1 represents the harmonic mean between the precision and recall. So we have TP is the true positives, Fn is the false negatives, Fp is the false positives, Tn is the true negative.
After pre-processing the data is divided into train set and test set with 80% and 20% of the sizes respectively. Then the kernel model is trained with 5 nearest neighbors and artificial neural networks is trained on 500 epochs. They have predicted all the examples in the test data correctly. On the other hand, decision trees have misclassified 7 examples in the test data set, and logistic regression have misclassified 89 examples in the test data set respectively. After calculating confusion matrices on all the models developed, accuracy and other metrics were calculated accordingly. It was found that KNN with 5 nearest neighbors and artificial neural networks had 100% accuracy, whereas decision trees stood second with 99.56% accuracy, and logistics regression stood third with 94.52% accuracy. All the other metrics have been tabulated in this slide. This project mainly focuses on classifying the mushrooms as edible or toxic. The dataset contains 22 physical properties of the mushrooms, on which 4 models were built using these 22 attributes. The 4 models that were built as a part of this project are k-nearest neighbors, logistic regression, decision trees, and the artificial neural networks. It have been observed that the artificial neural networks and the k-nearest neighbors have outperformed the decision trees and logistic regression with 100% accuracy. This project can be further extended to classify the mushrooms based on the image processing, or to improve this classification process by observing the microscopic aspects of the mushroom. This is an actual demo of how the user interface looks like for the mushroom classification project. Since artificial neural networks and k-nearest neighbors have achieved an accuracy of 100%, these two models were used as a part of the front end to predict the edibility of the mushroom. This user interface actually accepts 21 features of the mushroom. The attribute wheel type is removed from this choice because wheel type had only one unique value over the entire dataset. A choice was given, the end user was given to choose among the two models, that is among k-nearest neighbors and the artificial neural networks. Let us pick a random choice for each of the attributes and make a prediction using the artificial neural networks. For this random selection, artificial neural networks have predicted that the mushroom is actually poisonous. So let us pick a sample from the original dataset and make the prediction using the k-nearest neighbors. The actual class attribute for this selection is edible in the original dataset. The actual label in the dataset for this record is edible. So let us check how the prediction looks for this record using the k-nearest neighbors. K-nearest neighbors have actually predicted correctly for this sample. So this is the end of the demo. Thank you.